Maryland, I'm sure. So it's a great honor to welcome Dr. Don Boesch from University of Maryland Center for Environmental Sciences, where he was president for a very long time and also served as the Vice Chancellor for Environmental Sustainability for the University System of Maryland. And Dr. Boesch is going to talk about a study for sea level rise in the Maryland region, which is of a lot of interest to iHARP folks. So with that, Dr. Boesch, it's all yours.
Yes, I'm going to share my slides, share my screen. And so I now need to bring it up. So how's that on your end?
Yeah, can see it.
Great. Well, thanks very much. And it's really a pleasure to be here. We always like to cooperate and collaborate with other institutions in our great university system here in Maryland. It's one of the points of pride that we have. And so I'm going to walk you through a process that we did and we do periodically here in Maryland, and that is to develop science-based sea level rise projections for planning the future. Maryland, as this photograph behind would indicate, would demonstrate, has some low-lying regions along the ocean and its large shoreline around the Chesapeake Bay. So not only do we have a lot of vulnerability with respect to shorelines, but there's low-lying land, which is subject to inundation and shoreline erosion and all sorts of things that are starting to develop, including salinization of low-lying agricultural fields and so on. So it's a big deal here. And so we've developed this process by which we use experts to develop projections based upon the newest understanding. So as I said, we've done this several times, and really it started in 2008 when we did Maryland did its first climate impact assessment. So this report, Global Warming in the Free State, was produced, and it's got one section of it that deals with sea level rise. At the time, I think we had the IPCC AR3. We had other literature that was coming out that was giving higher projections based upon semi-empirical sort of statistical approaches. So we used what we had at the time. And in 2013, we decided to update it. And the reason we did that is that the National Research Council, National Academies, did a report on sea level rise projections for the West Coast, California, Washington, Oregon, that was actually commissioned by Arnold Schwarzenegger when he was governor of California. And so we used the methodology there, which was more of an expert opinion methodology, and adapted it to Maryland. In 2018, AR5, the fifth assessment, had come out, and we decided to kind of build on that and use that to develop these sea level rise projections. And so that's where we've continued since, using the latest IPCC projections. And I'll explain that, why we do that as we get into this. So this last report came out this summer at the end of June, sea level rise projections for Maryland 2023. And that's what I want to tell you. You know, it's one of these things where, scientists were always complaining because politicians and policymakers don't listen to us. In this case, be careful what you wish for, because in 2015, the Maryland legislature basically put into law, as part of a bill that created the Climate Change Commission, that my institution, UMSE's, University of Maryland Center for Environmental Science, had to do these updates every 5 years. So we now have a mandate to do it, a requirement to do it. So we did it again 5 years later in 2023. Now, first, I don't have to convince you, but here's some actual data that shows sea level rise at various tide gauge locations. This is based on tide gauges. Here, and all of these are in the Chesapeake Bay within Maryland. And you can see that all of them have, first of all, a rate term, a linear rate term determined from this period, about 1975 till 2022, in this particular paper. And you can see these rates are somewhat different, but they're generally similar. And the differences among the locations are basically, we think, largely, almost completely due to differences in the vertical land motion. These are relative sea level rise. They're measured by tide gauges. So what you see here is that we do have some variability in the rates of subsidence, in the rates of vertical land motion. And the other important thing to look at these in terms of these graphs is that there's an acceleration term computed here. Is that what is the rate of acceleration during this period? And you can see they're all accelerating positively, and that some more than others, the Annapolis site a little bit more than others. That may be an anomaly, but anyway, we see a consistent rate of acceleration in the annual rate of sea level rise. So what we say here is that you've got this variation since 1975, and that the rates of acceleration are about, in other words, about 0.07 millimeters per year faster each year. That acceleration rate is. Generally, though, we don't see, and you might be familiar with recent literature on recent acceleration, like in the last decade or so, really rapid acceleration of sea level rise along the southeast coast and the Gulf Coast of the U.S. I won't go into the reasons of that. You can look at that literature, but we don't really see that here north of Cape Hatteras. So this more recent acceleration in the actual record. Now keep this in mind, because we'll be coming back to these sort of empirical data where we look at the past rates of sea level rise from tide gauges, and also we have now satellite measurements where we can look at regional rates of sea level rise of the ocean and do that as a check of what's actually happened and what that might indicate if we just extrapolate with the acceleration terms into the near-term future. Beyond into the long-term future, you can't really do that because, as you know better than I, ice starts to melt faster and all sorts of other things, and all bets are off. And it really depends on the amount of warming of the globe. This is a good empirical check also on shorter term projections. So you're all familiar with the IPCC methodology. It's really based on, many scientists who work on adaptation or impacts of climate change don't really pay attention to these scenarios. They say high, medium, low, just sort of arbitrary, but they're actually very directly tied to emissions pathways. So here are the emissions rates for the 5 scenarios used in the 6th assessment. Importantly, the 6th assessment added this one, SSP 3.70, because this high rate that, the high rate we like to use as scientists to show how bad it could be is really implausible. We really have to, we'd be essentially tripling the rate of emissions by the end of the century. That's not going to happen. And worst case is probably this one. And of course, we're trying to achieve the net zero to reach the 1.5 degree warming goal of the Paris Agreement. That's this green scenario at the bottom. So in looking at this, what do we tell people? Here we have a very practical approach where we're providing good advice about what the world would likely be, not what the world could be if everything went crazy, but what it's likely to be. And secondly, in Maryland, we are one of the states. In fact, I would say we are kind of a leader at the moment for aggressive strategies for mitigation, for reducing our emissions. So we have a law in Maryland that says we're going to reduce our emissions by 60% from a 2005 baseline by 2031. It's only, let's 8 years away. And we're actually not fully on track, but we're not doing bad. It's within reach. And then go to net zero, not by 2050, but by 2045. So we want to combine that approach in Maryland, thinking of mitigation and adaptation all in the same framework. So if you think of that, then where are we with respect to these likely scenarios? Well, we've already bent the curve a little bit, and this is very recent. International Energy Agency outlook suggests that we might reach a top maximum emissions from energy-related CO2 emissions this year. It will likely decline. Now, the problem is that we're not declining fast enough based upon the policies that nations have adopted. Even the pledges that they've made won't be sufficient to achieve, to keep at 1.5 degree warming, net zero by 2050. And so we're likely to be somewhere in this range. And so that we've selected this blue scenario, SSP2 4.5, sort of the intermediate scenario, is the most likely environment we'll probably face during this century. And it's really kind of a pessimistic scenario because it means we won't meet these goals as a world, but it's actually more realistic than the continued growth of emissions. Even SSP 3.370 assumes that we double emissions by 2050 rather than reduce them. So this is where we've really focused. Now we've paid heed to the two on either side, the low emissions and the high emission scenario, one that would meet the Paris Agreement of 2 degrees warming, and this other new 7.0 scenario is within that range. But we're really focused on what we call here current commitments situation. Now that's important as we get into talk about the polar regions and ice melt. This is a big deal. This is an important issue where we find ourselves on that spectrum on meeting the Paris goals is very consequential. I think many of you know that more than I do. So, there's really not a lot of complicated math for us to do because it's all been done to translate this to local sea level rise. The IPCC they didn't include it in the full report, but they ran models that basically allow you to project sea level rise on those emission scenarios for many spots in the world, anywhere there's a tide gauge in the world. So if you go to the NASA AR6 sea level projection tool, you can pull up a site, you can home down and pick up a site, one of the 13 sites here. And then within that, you can look at the projections for different mission scenarios and different time frames. And importantly for you is that I showed you the pull down thing here where you can actually look at the total sea level rise, that is the relative sea level rise, the vertical land motion component that I mentioned, the stero-dynamic sea level, which means how much the warming of the ocean has affected your location. Some areas warm faster than others. And then also there's an important component to that to do with ocean circulation. So we happen to be seeing now, and there's evidence mounting that we have the Gulf Stream, which moves up off our shore and then heads over to Europe, is slowing down. That has a lot to do with what's going on here south of Greenland, but I won't get into that. But the effect is that current, that massive current that pulls water off of the continental shelf, off of the Atlantic coast of the U.S., is that slows down. Strangely, it strikes people as not intuitive that results in higher rates of sea level along the shore because less of that water is being pulled offshore and out to the ocean with that fast flowing current. So you can look at that as well. And you can look at the component of Antarctica, Greenland, as well as glaciers that contribute to that, your sea level rise in any given location. So marvelous tool. If you haven't dealt with and played with it, please do. I don't have the URL, but you can just Google it and easily find it. It's a very powerful tool. And so that's what we use to develop these estimates. And so the first thing I want to stress here is that if you look at this and look at these projections for our part of the world here in coastal Maryland, it turns out, we draw the short straw, and that sea level will rise faster in Maryland than it will as a global average. Why? There are multiple reasons. First of all, the contribution of glaciers is about the same in Maryland. In fact, actually is slightly less in Maryland than it is globally. The concentration of Greenland melting is quite a bit less than the global average. Why? Because we're close to Greenland. So that mass melts, the gravitational pull of that mass on the ocean is relaxed. So the effect on sea level rise is greater farther away from that source. Conversely, Antarctica works in the other extreme. So we're very much mindful here in Maryland and throughout the United States of what happens in Antarctica doesn't stay in Antarctica. And that's particularly important as we go forward in our part of the world. Land storage is estimated in this. And then here's this stero-dynamic effect, and it's due to the fact that the ocean off of our coast is expected to warm faster than the global average, as well as these current dynamic processes that are likely to rise, sea level rise. So we expect to look at higher rates of sea level rise. This is without vertical land motion. That's factored, that's taken away for comparison. And you can see it's, I don't know, 10% higher, so slightly more than 10% than the global average. So here are the projections. These are just the medians for the scenarios that I showed you early, the emission scenarios. Now, one of the things that the AR6 did is that the previous the assessments, previous IPCC assessments didn't do. It talked about them, but it really didn't incorporate it very much. Is what you're all about. What happens if the ice in the polar regions goes a lot faster? There's a lot of uncertainty associated with it. There's a lot of ambiguity because experts don't agree on how fast that can happen. So what they did in IPCC in the fourth assessment, in the sixth assessment, is they didn't do it for all 5 scenarios, but they did it for 2. These 2 here, the low end, the one that will meet the Paris Agreement, and this ultra high emission scenario. You see LC, these are including low confidence processes. Keep that in mind. We'll get back to that toward the end, because I think it relates to what you're trying to do. And the other thing to keep in mind, and I mentioned where we could use tide gauges and satellite measurements, observations, and extrapolate those using the acceleration terms that we've observed. Here's where we are in beyond 2050. So you really can't do it. So they're well within the bounds. they cover the bounds of these median projections through the middle of the century. So we can use as a check about what advice we give in the short run. Beyond that, of course, they diverge, and they diverge quite a lot, depending upon whether we meet either the 2.0 or 1.5 degree Paris goals. The other important thing here is that if we meet the 2 degree Paris goal, there's not a lot of difference between the low confidence, that is adding this uncertain and ambiguous ice melt, than there is compared to the high emissions. So there's some sort of a tipping point here, presumably, in which the warming really starts to melt things faster, and then you get these really high-end projections. Now, keep this in mind, because we'll get back to it toward the end. So taking all of this, and as I mentioned, we're really focusing, we're going to focus a lot of it. Here are the 5 scenarios. These are the means. These are the 17 to 83% range of probability, likelihood, and that's what the IPCC terms as likely. And then here are the 5 to 95% ranges. So you can see, as you said, as they vary, and this is by 2100. So that emissions reduction, emissions stabilization and reduction matters a lot in terms of what we will get toward the end of the century. It's basically almost double the risk if we don't, if you believe the high-end scenario here. If we look at these low confidence scenarios with more rapid ice melt, you can see it doesn't really affect the 2 degree warming goal scenario, but it has a major effect, particularly on the long tail of the distribution for the low confidence, high ice melt projections that IPCC used. So one of the things we struggle with is, how do we use these? Given that they're low confidence, how do we tell people, decision makers, that I've got some, I tell you what, ice might melt faster, but there's disagreement among the scientific community, and I don't have much we don't have much confidence in it. How do we tell them to use that? keep that in mind. That's a challenge that we face going forward, to be prudent. Because keep in mind that if you're talking about adaptation, building defenses, moving people, all of those things all come with a great cost. So we just can't say, well, to be safe, you should assume, 1.5 meter sea level rise by the end of the century to be safe. Well, I mean, that's a huge cost to society that could be spent doing other things. So we have to keep that in mind as we convey these results. So here is, as we again, the same box and whiskers approach here. Here's the one we're focusing on to say, let's rely on this primarily, but keep this in mind. Keep, we might make 2 degrees in mind. We might be able to save some sea level rise, and we might screw up and let our emissions grow. So that's the range of probability we think, plausibility for this century. So here we have, using the median is the best estimate, the unlikely range, and as well as the 5% chance of exceedance. And then here we brought in these low probability of exceedance from these low confidence models to say that, well, we think it's going to be in here, but if things go haywire and in the Antarctic in particular starts to melt very rapidly, it could be higher, but we don't think it's going to be higher than 1.5 meters. That's how we use these low confidence projections. So we hope that this will give decision makers, depending upon the risk you take. So for example, tomorrow I'm going to be going to Ocean City on the ocean side to talk to a TV station about sea level rise. And so if you were planning for beach nourishment at Ocean City and protection of that amenity, you don't want to necessarily assume that it's going to be up at the 5%, only a 5% possibility of range. You might want to do that if you're building a building there, but you want to be close to what we think is most likely. Same thing if we're trying to restore wetlands for adaptation purposes or so carbon sequestration purposes, but for other things where you really have a high risk investments and there's substantial loss of property and lives involved, you might want to use a lower probability level. So we did this in 2013, and another group has taken this and developed practical guidance in plain English for like county planners and so on, and they're in the process of doing the same thing now. So I mentioned I was going to get back a little bit to the low confidence processes and how those were developed and how the work you're doing might affect the thinking involving those. Mind you, again, keep in mind that I said before, here's a good point to speak. Now, we're not, it's not wise, it's not prudent to jump at the latest publication that just came out that says, oh my word, Antarctica is going to contribute 3 meters of sea level rise. We got to run for the hills. We're developing these for the long range, and we want to use consensus science. So we've decided we're going to use the IPCC process and let them sort out, just as they did this last time, how to deal with these low confidence, the ambiguity in the estimates. So the IPCC, and you should go, if you're not familiar with it, there's a paper by Bob Kopp et al., who was involved in our committee that developed this report in Nature Climate Change, which really explains in clear detail, and something that's not done in the IPCC report very well. And it's by the authors of this section of the IPCC about what they did and how this can be used. So they used 2 models that this is of ice sheet loss. Okay, I think I'm not sure. This may be Antarctic. I think this is Antarctic. I mistyped it here. But these are models of ice sheet loss. You can go into IPCC and understand which ones they are, but they're consensus models for the most part. And you can see how they differ. And this is by 2100 global sea level rise. They differ, especially in terms of the long tail of the distribution, but they're in the same range. And they looked at two other models. One is this model by DeCanto and Pollard, and it's continued in many forms on this on the marine ice cliff instability issue. And as well, and that's this orange curve. You can see it's higher rates, and this is assuming that that happens. This is the low confidence predictions. And then they looked at another estimate, which was done by structured expert judgment, elicited through an elicitation process. And those experts had a broader, some experts, small number of them, had thought that sea level could rise a lot higher. So they combined these to develop these low confidence projections. And so you should understand, sort of where they come from, because if you're talking about research that's based upon, marine machine learning and understanding, rates and processes and so on, it's going to play in this game of how do we relate this to other kinds of estimates of polar ice sheet loss. You can see how that affects the cumulative frequency distribution and then skews this way off to the high end of the range, and you can see how the likely ranges are affected as well. So in this report, they clearly indicate that because the IPCC authors assessed that there was limited evidence regarding and low agreement on MICI, this is the marine ice shelf instability, as well as potentially on other processes considered by experts in the structured elicitation, the judgment call. The broader P boxes, including these studies, were judged to have low confidence, which in IPCC parlance means don't count on it. We just want to tell you it's out there going forward. So one of the challenges that we have is, as you know, there's something coming out there are just two papers, I think, that I know of this week, in a week or so, week and 10 days, that really deal with this question of more rapid polar ice sheet loss. This is one that you may be familiar with by Naughton et al. It got a lot of press, including right up in the Washington Post here in our area by two reporters who covered climate and I know well and are generally pretty reliable. And it's kind of it's kind of not exaggerating, but exciting people that things are going to happen, because the point of this paper is that it really doesn't matter if you mitigate emissions. The processes are in place that are going to warm the Antarctic region faster. In fact, this paper is really about the ocean and the ocean warming. And then it assumes that translates to ice sheet loss by some other process. They didn't do there's not an ice sheet model that's really a component of this study. So here, our well-known friend, Michael Mann, who is active not only in climate change generally, but is published on sea level rise. But he's also one who is promoting this view that we really need to alert people, yes, that there are risks, but that some of these risks can be avoided. So he's thinking of it from a standpoint that's expressed in his book, Our Fragile Moment, his new book. And he tweets, a new study on West Antarctic ice sheet collapse is quite literally a textbook example of Andy Rivkin, the former reporter from the New York Times, whiplash phenomenon. So we get like a study a week, saying, oh, it's going to be this, oh, it's going to be that. We're back and forth on it. And he also then followed up and said it's worth noting that Richard Howley, who's another famous person in this field of ice issues, my go-to person on ice sheets, doesn't think the ice sheet model of the new study on West Antarctic ice sheet collapse is up to snuff. So as you do your work and you're developing new knowledge based upon the approaches you're using on polar ice, be mindful of the fact of the process that lies ahead with respect to how we bring that together with other views of scientists, develop scientific consensus, how that's translated into practical ways like using these probability distributions that Bob Kopp was really kind of the leader on in IPCC, into bringing something that can practically be used in the real world to provide sound judgment, provide sound recommendations for people planning the future in the near term and as well as in the next century. So I think that's about it. Here's my contact information, and I'm happy to, if there's time, answer any questions.
I think several questions started coming in. Thank you so much, Dr. Boesch. Shashi, did you want to kick us off with your question?
Okay, all right. So Dr. Boesch, thank you again. It's a very comprehensive talk. You learn a lot about sea level rise in the effect of also Greenland and Antarctica. But one of your slides had a bullet saying emissions don't have much effects till 2050. And we were curious what that meant because, at least the naive reasoning is that emissions have caused global warming, which has increased melting in Greenland.
No, what it means is the emissions from now to 2050 don't have much of an effect. So it's perspective, not it's not a retrospective. Obviously, emissions have already had an effect, but which pathway we're on in the short term doesn't have a huge effect on how much sea level rise we're going to have in 2050. What the practical reason of that is that, okay, then we can give you one number. We can actually match that up with real extrapolations of real observations to give you great confidence that you better prepare for this range of sea level in 2050 because the data as well as the models kind of match up. Beyond then, it really depends more and more on what our emissions pathway is. Now that emissions pathway starts now, right? So the emissions that we achieve now between now and 2050 have a huge impact on sea level rise in the latter part of this century and into the next.
Thank you.
Sahara, do you want to say a question? I'm not sure if Sahara can hear me. Sahara, who's one of our PhD students, had a question. How do we get the probability reference point in the last plot where it specifies if emissions double, is it based on approximation or counterfactual predictions?
The scenarios, the pathway scenarios that the IPCC used were, and it's important to understand that because they affect not only projections of climate change, but they also inform the mitigation strategies that we have going forward. So if you've only read, the working group 1 of IPCC, shame on you. You've got to read working group 2, but also working group 3 to see what we need to do to get to those pathways. So and one of the scenarios that were the high and very high scenarios used in the IPCC assume that in the highest one that we, I think, increase by a factor of 4 or 5 at least the emissions from what we have now. Then that's not realistic. I mean, first of all, we probably can't get enough coal to do that. And that was always, assumed kind of as a high boundary just for framing the argument. Still, a lot of scientists are using 8.5 scenarios, even though it's implausible. And so they developed this other scenario, but even that, the 7.0 scenario assumes from the time the IPCC report was written to 2050, we're going to double emissions. We're going to continue to grow emissions. Now, the other graph I showed you from the International Energy Agency showed you already we're leveling off. We still haven't seen the peak. We thought we saw the peak in COVID, and then of course it shot back up again. But looks like now if we accept the policies that nations of the world actually have in place, that we're going to be on a downslope. But that downslope in terms of emissions is not nearly fast enough to meet the Paris Agreement goals. Now we're all going to be working to that. So our logic is let's use that modest downslope as the assumption, and it's probably not going to be worse than that. and it could be better than that. Does that help?
Yep, absolutely. And I'm sure Sarah, I don't know if she can hear or she'll catch up to with the response. Thank you. I think we have other questions from Dennis, maybe. Dennis, you want to speak your question here?
Yes. Yeah. Thank you for the talk. I'm wondering, how important are stero-dynamic processes in the bay? Do they have an impact on sea level change? Because those are not accounted for in the global IPCC projections, of course. But I'm wondering, do they have any impact on sea level, or is the sea level projection that you get off the coast good enough for inside?
Very good question. So if you go to the NASA AR6 tool, you will find that the contributions, other than vertical land motion, for all of those stations within Maryland are the same. So there's no real difference. If you go and look at that reference by Easer et al. That I showed you the actual curves from, he makes the point that there is some within the bay effect. I would say that that's not it's not a mainstream view at this effect, and it's small. So it really means that within this region, we're going to have generally similar rate of ocean rise, and it's going to vary from place to place because of vertical land motion differences. So that's very important in the bay, because even in Maryland, I showed you there's some differences. So the one that has the highest rate of sea level rise observed was an area where we seem to have more groundwater withdrawals and depletion. So you've got enhanced subsidence due to groundwater withdrawals. If you go down to the southern part of the bay around Hampton Roads, the Norfolk area, they have a much higher rate of sea level rise because of all the groundwater abstraction that had taken place in the area, not necessarily just in like Norfolk or Virginia Beach, but elsewhere in southern Virginia because of paper mill withdrawals and things of that sort. So they're actually now trying to think about how do we like inject treated wastewater back into the groundwater to mitigate that induced subsidence.
Thank you. We have one more question, Jianwo.
Yeah, thanks for the talk. I'm trying to understand how you from the global projection to local Maryland projection. What is the main methods you're using to have your projection for local Maryland areas? You saw multiple local area in Maryland and also for Baltimore. That's the first question. That was from method perspective. What additional factors are you considering to make a local projection? Second is, I think that you probably explained a little bit, but I still don't quite get it. You're seeing Baltimore area, and they have even more effects from Antarctica than Greenland. I still don't know why so far from Antarctica we still get affected more than Greenland.
Right.
Yeah,
Right.
2 questions. Thank you.
Yeah, I'll take the second question first because that's easier and straightforward. The science in this is very well known in that it's called the sea level rise, fingerprints from ice loss. So if you're in let's take the continent of Greenland. As Greenland melts, it loses mass, right? So it adds that mass to the ocean, which extends all over the whole ocean. But because of that mass is lost, its gravitational pull on the ocean around Greenland is less. So that interestingly, as Greenland melts, sea level rise around Greenland, sea level actually increases around Greenland because of that reduction of the gravitational pull. So the farther you're away from it, the less gravitational pull. So enigmatically, the farther you're away from the source, the greater amount of sea level rise you get from either polar ice sheet or glacier melting. I mean, it does, the average person, it just doesn't make sense, but it's physically, it's well established. The other thing is on the local issue. One of the reasons we put in this graph that I showed you about why and explained why sea level rise in Maryland is going to be greater. We expect it to be greater than the global mean, is to get people to understand that. You just can't take the average for the world, we're a little bit more vulnerable, but also to get them to think about what's happening in the world, both with respect to the contributions of Greenland and Antarctica, why we should be particularly concerned about Antarctica, even though it's so far away, and also what's going on off our coast with respect to the ocean. That's already been, showing these in the southeast anyway, these really rapid rates of recent sea level rise. We don't really know whether that's going to continue. That could be a climatic cycle that's taking place, and there's a lot of research and so on that's going on to that. So we wanted to try to explain to the educated layman about why that takes place. Now, what I didn't tell you in the talk is that there's a lot of other things other than global mean sea level that matter here. Because what happens is that, and it doesn't matter what the mean is, but if you get a very high water levels due to a storm, a hurricane, for example, a tropical storm, actually that storm surge could be much greater than that. The base of that storm surge, the mean level, of course, is increasing, so that the greater the storm surge effect would be. But the other thing is that we have these what's often called rainy day flooding or high tide flooding, which is not necessarily related to a major storm, but in the Bay region, sometimes it's related to strange lunar cycle dynamics. But in the Bay region, it's really affected by meteorological forcing. So if we get strong winds blowing up the bay, you're going to have higher water levels. And so we didn't do it in this report, but others are working on this issue of how does that affect these extremes? How does it affect storm surge and high tide flooding? And that's where we really need to think about in terms of planning, for safety, as well as for things like agriculture. Because once these fields flood on an extreme event, the salt gets in the soil, and it doesn't recover. So it's those extreme events adds another layer to the complexity, and we're working on, and there'll be other reports on.
Got it. Thanks.
Great, thank you. There's lots of good links from Christopher in the chat as well. I think there's another comment from Mike. Mike, did you want to add anything here or raise a question?
Oh, it wasn't a question. Sorry, it was just in addition to the explainer that Dr. Boesch was giving on the gravitational effects of sea level rise and sea level drop around where the ice is melting fastest. There was a popular press article that a few authors and I had co-authored a couple of years back for a Scandinavian newspaper that gave some good graphics on the why, when ice is lost around Greenland, why sea levels around Greenland are dropping as a result due to this.
How did I do, Mike? Was it a reasonable explanation?
Yeah, it was a good explanation. Just I think sometimes graphics help with it. So,
yes, it does.
So I posted that just.
Well, you didn't see Mike waving my hands, and that was my
right. I mean, clearly, yes.
So I have a question, trying to connect the dots for what we are trying to do in iHARP. There are all these projections based on the different scenarios from the IPCC, and they are really related to the anthropogenic activities that lead to sea level rise. We are also trying to look at different processes in the polar region. What's changing in the ice sheets, what's changing under the ice sheets, what's happening in the atmospherics. If you wanted to go at a granular level on the different contributions, even coming from Greenland or even coming from the Antarctic, are there studies that we should be looking at to see the contribution of different components, even on just Greenland, for example, ice sheet, atmospheric, hydrologic, and so on?
Yeah, I'm not an expert in the field, but I mean the last IPCC assessment did a very thorough job. It had some excellent people, a range of people with different opinions on the team that did it, and there's a literature there. But this is a fast-moving field, and there are more papers coming out all the time, including this one that I showed you just about a little over a week ago. So, but one of the things I think that's actually I'm an oceanographer. I'm not a glaciologist, not an expert in Earth's the cryosphere. But the thing that's surprising actually is what's how the ocean's responding in ways that we still don't fully understand. And also in particular, the Southern Ocean and current circulation and heat supply into the waters around Antarctica. I'd pay particular attention to that. And also in Greenland, there's a lot of the things that we have the hardest time dealing with it's not the melting and net dynamics from snowfall and temperature on the terrestrial part of it, but it's what's happening underneath, with respect to the ocean warming. But I'm an oceanographer, so I'm biased that way. But I'd say that's pretty. Another one, for example, I mentioned this curious and actually very alarming rapid increase in sea level rise, measured, from North Carolina all the way down through the Gulf on tide gauges and so on. Is that this seems to be let's talk about the Gulf of Mexico. It seems to be due to a substantial warming of the Gulf of Mexico. And that warming is not as we might think of it, because the air is warmer, is that it's importing more warm water. It's importing more heat from the Caribbean. It's got one little entrance between Cuba and Yucatan, where all that water flows, and that the Caribbean is heating up like crazy, and there's warm water coming in. And that means that the water warm water isn't on the surface, but it's at depth. Now, why is that important? One is that increases the volume of the Gulf. That affects sea level rise. But the other thing it does is it provides a nearly inexhaustible supply of heat for rapid hurricane intensification. So you've seen more and more of this evidence. In fact, I can't verify, I don't vouch for the science, but I've seen reports that this Acapulco hurricane rapidly intensified, in part because it was drawing heat from the Caribbean and the Gulf. I think it's in the Pacific, but it's an isthmus, and so it's drawing heat in there too. So this is a double threat issue of both sea level rise and rapid storm intensification. And the problem is that we don't know whether this is a secular trend that's going to continue as a long-term effect of climate change and warming the planet, or whether this is a climate cycle that's coupled with, decadal dynamics that take place in the ocean. And that seems to be pretty important to understand. Is this something it's a trend that we have to really be worried about, or do we expect it to turn around and the rate of sea level rise to slow down or maybe even decrease for a little bit? So those are really important questions. The thing about the sea level rise thing is that it's the whole world. I mean, it's all connected to the oceans, the atmosphere, and the cryosphere. And so you can't take a local approach to help to sort this out.
Yeah, that's true. If I may just tease that last bit for a second. Many years ago, I had gone to this visioning workshop from EarthCube, which is an NSF program, you may remember. And several scientists studying a square foot of Earth were talking how they don't connect with each other. They're studying probably the same parcel of land, but they're looking at it from so many different perspectives. Do you think that we have a good tipping point of research where all these components are connecting and talking to each other to study the sea level rise?
More than ever. Whether it's yet where it needs to be, I don't know. But I mean, if you look at the literature that's emerging on this issue of the polar regions and sea level rise, and I mean, it's really international. It used to be the Americans and the Europeans. Now there's a lot more work between Americans and Europeans working together. But now the Chinese are in this game a big time as well. So it is really an international community of science, and as it should be. Mm-hmm. And I'm looking for answers, and I'm hopefully that they'll creative minds will come up with it.
That's great. Right. Other questions from folks?
I have one more if there's time. So you mentioned about the roles of the ocean and ice sheet. for the iHARP is about the polar area. We also covers the polar, Arctic Ocean where there are a lot of sea ice. So what we know, sea ice does not directly contribute to sea level rise because it's already in the water, but it's still play a role to some knowledge. What do you think of the contribution of the sea ice to the sea level rise?
Well, I mean, in the direct way, if it's floating ice, if it melts, it doesn't contribute to sea level rise. Indirectly, though, as if the ocean warms and causes more ice to break off, whether it's ice sheet instability or mass movement of Antarctic or Greenland bound glaciers. I mean, that does contribute, and that ice might float around a while before it melts. So in the specific direct way, floating ice doesn't contribute to sea level rise, but warming contributes to more floating ice, coming off of land into the ocean.
Thanks. Yeah.
That's great.
Yeah.
Yeah, Shashi, go ahead.
All right. I had actually a broad question, or more like ask for advice. So I don't know if Professor Janeja has given you an overview of iHARP project. So
Not,
I mean,
not so much.
I have a very general one just from the website, but
okay. So we were looking for advice on what are the best places for these data-driven techniques to contribute to the sea level rise science or discussion or debate and so on.
Well, I don't know this field very much in terms of the use of AI and machine learning, but in areas that I am more familiar with, I would urge you to really connect with the experts, the dynamicists, who are trying to figure this out. Because one of the worst things you can do is come in and just because I can run massive amounts of data. I'm smart and I can solve your problems better than you can. That's a wrong approach. I mean, that's probably doomed to failure. But if you can then work with those dynamicists who are working on models and so on to do that, and let them help you understand how you can bring these techniques into better understanding and maybe answer some questions that they can't. That's the productive space that I think this has.
So may I ask a follow-up question? So sometimes, it can be sped up if we had sort of like a panel discussion, right, where you have people from both sides and where this question is kind of posed, right? Where are the missing physics? Where is the need for empirical models? Where is the value for data? And we get perspective from both sides, and it triggers a conversation with the audience as well. So let's suppose, that was a path. What would be the right meeting? I mean, how could you bring the two groups together to have a conversation?
I think that could help. I mean, AGU, other organizations are in this. There's a AGU and other oceanography groups sponsor this annual oceans meeting, a biennial oceans meeting, which is coming up in February. Okay. But I actually think, I've been to, I can't remember the number of meetings that I've been to, conferences that I've been to, and it's always good, to hear thinking and so on. But I tend to think that it doesn't. I mean, those conferences and panels aren't very successful in promoting real dialogue. They're largely, everyone wants to make their presentation, and there's a little panel discussion, but everyone makes their point. I think some sort of a small sort of a workshop type of approach where you bring folks together and have them work intensively for a few days, trying to jointly educate each other, because most of I would imagine, I don't know, but I would imagine most of the authors of the sea level rise part of the IPCC, they're not experts on machine learning. So you need to help them understand what this can do. They need to help you understand what the problems are, what the unknowns are that need to be solved. And that can take place better, I think, under kind of a structured workshop type of an arrangement than a meeting, in a big meeting.
So that's an action item we should take back, especially as our all hands meeting is coming up in Alaska in June. Maybe we should consider inviting folks like that and having conversations.
There is one of the things that I'm on two panels, advisory panels at the moment, dealing with this issue one way or another. One is the NASA. NASA has a sea level change team, in which they actually fund a lot of this work, polar region and other sea level work, more than NSF, more than NOAA and other organizations on that. So there is a team, and they're actually in the process of recompeting for the next phase. So there'll be another group of people in it. There's a guy, a scientist by the name of Ben Hamilton, who is the leader of that team. He'd be one person I'd approach right away and saying, how can we get a dialogue about how we can bring this machine learning opportunity into your field. The another area, I mentioned Bob Kopp's name a couple of times at Rutgers. He's really the person who's done this probabilistic projections and so on. He's very much attuned to practical uses of this. He has an NSF center that's part of the NSF has two oceans and people centers, one dealing with tsunamis and one dealing with sea level rise. And he's at Rutgers, and he's trying to take this science and bring it to bear to the megalopolitan region, New Jersey, New York region, and has engaged a lot of stakeholders and so on. But he really understands the science. I mean, he was one of the main guys in the IPCC report. Those two folks, and Bob works with the NASA folks too. So I mean, those are two people I would reach out to and see whether there's some opportunities to pursue this.
Those are great connections, and I imagine, Dr. Boesch, will reach out to you again as well to keep going, to keep having this dialogue.
Happy to.
Wonderful. And now we have more closer connection with UMSIS with the new grant, so hopefully we'll interface with that as well through other opportunities. Wonderful.
Great.
Awesome. So with that, I really appreciate the talk, and this is continued conversations for sure. Thank you so much.
I enjoyed the questions. Thanks very much.
Wonderful. Thank you. Thanks everyone. Bye.
Bye.